Hi, welcome back. In today's video, we are going to review how we can create an order dictionary with three key value pairs and print all the elements. And we are going to then learn how we can have access and print a specific keys value. So first of all, when working with order dictionary, we need to import them from the collection module. Then we are having the creation of order dictionary. We, for example, want to name our order dictionary to be OD. Then it is equal to order dictionary with empty parentheses. So this is how we create an order dictionary. Now let's have our elements, keys, and their associated values. So the first key is name. It is associated with the value Alice. The second key is age. It is associated with 25. The third key is city, and it is associated with string New York. So we are having three keys that are name, age, and city. Then we are having three associated values, which is Alice, 25, and New York, respectively. In order to print the ordered dictionary, we can simply use the print function. We write down order dictionary message, and then we write down the name of our order dictionary. So this is basically how we can have our order dictionary completely being printed. We are having the key name. Its associated value is Alice. We are having the key age. Its associated value is 25. And we are having the key city. And its associated value is New York. Then we are having the access to a particular key in our order dictionary. For example, we use the print function to have access the value for the key age. So for the key age, the value is 25. Now, if we want to print 25, we can simply write the following. The name of the order dictionary, then we are having the name of our key here, and when I run this code, we see that number 25 is being printed in the output. So in this video, we reviewed how we can create an order dictionary, how we can have different elements, the keys, and their associated values. Okay. Then we learned how we can print the order dictionary, and finally we reviewed how we can have access to specific value for a specific key. Thank you for watching. Hi, welcome back. In today's video, we are having another coding exercise with respect to ordered dictionary. We would like to have a tracking task completion order system in which we are having a list of, for example, a to-do list, and we want to mark all the tasks to be incomplete in the beginning and then update the status of, for example, one particular task and have it to be completed. And then we see how we can do it in order dictionaries. So first of all, we import the order dictionary from the collection module. Then we are creating an order dictionary for tasks. We call it tasks. So this is the name of the order dictionary equals to order dictionary keyword in parentheses, okay, empty parentheses. Then we are creating different elements. So we are inserting different elements. The first element with its associated value, the second key, let's say, with its associated value. So this one is the second element in total. The third key and its associated value. So task 1 to 3, and all of them are having the status incomplete because it's just the beginning of our work. So these are the tasks that we want to have, and it's a to-do list, and these are the status. All of them are incomplete. Then we are, first of all, we're saying that, okay, print the initial task list, and we are going to print that. So when I run the code, we are seeing that, okay, task 1 incomplete, task 2 incomplete, and task 3 incomplete. So we created an order dictionary with the tasks being incomplete in the beginning. Then we do some work, for example, and now the task 2 has completed. Now we need to mark it as completed. So we are assigning the completed, let's say, status to the task 2 from the tasks order dictionary. This is how we can do it. So we write down the name of the order dictionary, we then write down the name of the key, and it is equal to the status which is completed. Then we are saying that after updating the task list, sorry, here is, okay, now after updating the task list, we are printing the full task ordered dictionary, sorry, to see how it is. Now we see that task 1, it is still incomplete. Task 2, however, is now completed, and task 3 is incomplete. So order dictionary are very useful because we can have, for example, a track of tasks in a to-do list and check if one task is completed yet or not. If yes, we can update it easily, and then when we print again the order dictionary, we can simply trace to see how many tasks are labeled incomplete and how many tasks are marked to be completed. Thank you for watching. Hi. In this video, we're going to talk about chain map. So a chain map is a data structure, again from the collection module, that allows multiple dictionaries to be treated as a single unit. So it groups multiple dictionaries together while maintaining their individual identity. So we are going to have multiple dictionaries in one unit using the chain map in Python. For example, when you perform lookups, chain map search through the dictionaries in order and returning the first match it finds. So why do we need to use chain map? The first reason is that they are having efficient lookup. So instead of merging dictionaries, which creates a new dictionary, chain map allows us to have efficient key lookup across multiple dictionaries without copying data, for example. And then we can have overriding values. It helps to manage different layers of data where later dictionaries can override values from earlier ones. It's very important. Then we can have managing defaults. For example, it is useful for managing configurations with default values can be overridden by user settings. Okay. And finally, it's because they are having the scoped variables. So they are very useful in scenarios like variable scopes in programming, like local and global or built-in scopes. In the following, we are going to have some coding exercises with respect to chain maps. So we're going to learn how we can create them and how we can work with them and how we can access different dictionaries that are included in a single chain map. Thank you for watching. Hello everyone, welcome back. In today's video, we are going to have some coding exercises with respect to chain maps. So a chain map, we discussed that it is going to combine multiple dictionaries. So first of all, when we want to work with chain map, we need to import them from the collection module. Here we are having three dictionaries, dictionary 1, dictionary 2, and dictionary 3. The first one has two keys with their associated values. For example, dictionary 1 has a key A with value 1, a key B with value 2. Dictionary 2 has two elements again. The value 1 is the 20 for the key B, and the key C has the value 30, and also the dictionary 3 has only one element with the key D and the value 40. So these are our 3 dictionaries. Now we would like to create a chain map with dictionary 1 and dictionary 2. In order to do that, for example, we want to name our chain map to be CM, and we simply use the chain map keyword, and in parentheses we are having dictionary 1 comma dictionary 2, and this is going to basically use the first 2 dictionaries to create a chain map and assign it to CM. And a CM is a merge, let's say a combination of these 2 dictionaries. Then we are printing the initial chain map. So CM is being printed in the output. Here we see that initial chain map is A and B. These are the 2 keys from the first dictionary with their associated value. And then we are having the second dictionary now here, which is B and C with their associated value. So the dictionary 1 was having A and B and C was for the second dictionary. Okay, so A and B from the first dictionary and B and C from the second dictionary. So as you see here, this is the first dictionary and this is the second dictionary. They are combined in our chain map. So if I want to create another chain map, I can write down chain, for example, CM2. This is the name of my second chain map. Let me write down 2. Then I use the chain map keyword to, merge these 3 dictionaries, dictionary 1, dictionary 2, and dictionary 3. And after that, we write down this message, initial chain map 2, and we're printing the CM2, which is the name of our newly chained map. And when we print the CM2, we expect to see AB, BC, and D. So when I run the code, in the output, we see AB, this is from the first dictionary, BC from the second dictionary, and D from the third dictionary. So this is basically how we can create a chain map from different dictionaries. But then what if we want to access the values inside this chain map? In order to do that, we need to use the name of the chain map, which is CM, and then we simply write down the name of the key that we are looking for. For example, now if we want to have the value associated with the key A from the CM chain map, we write it like this. So it is going to find it in the first dictionary. Then you see that here in the first dictionary, we are having a key called A, so the value 1 is going to be printed. Then we want to have this B being printed, so we are going to have the name of the chain map and the name of the key. So this B is going to be printed, so this B overrides this B. Okay, so we can print this B in the output. And finally, if we want to, for example, print the value associated to key C, which is 30 here, we can simply write down the name of the chain map and then the name of the key. So when I run this code, we can see in the output we are having value of A is 1, value of B is 2, and value of C is 30. 1, 2, and 30 is being printed. So 1, 2, and 30 is being printed in the output. Also, if we want to, for example, access the values of the second chain map, we can do the same. So we use the print function and we simply write down value of, for example, D, value of D, then a comma CM2, then we simply write down D. So it is going to print the value associated with the key D from the CM2 chain map. Okay, so CM2, if you remember, we created from all three dictionaries, dictionary 1, dictionary 2, and dictionary 3. So when I run this code, we see here value of D is 40, which is indeed true. So this was how we could create a chain map from different dictionaries, and after that we could access the values from different keys. But how do we update these values? How do we update these values? So these values, in order to be updated, we simply write down the name of our chain map, which is CM here, then the name of the key, which is B, then it is assigned to a new number. So B, again, it is going to affect only the first dictionary, and B was initially 2, so now we are updating its value to be 100. So now we are updating the value associated to the key B from the CM chain map, and we are saying that after updating B in the chain map, we are printing the full chain map to see how it works, and also we are printing the first dictionary also to see how it can have impact on the first dictionary as well. So the first dictionary is A1, B2. Okay, so when I run the code, I come here. After updating B in the chain map, we see that A is 1, B is 100, and the rest of the chain map remains the same. So the initial chain map was A1, B2, so now A1, B100, and the second dictionary in our chain map was B20 and C30. So B20 and C30 remained the same. Also, after that, if you remember, we tried to print, oops, sorry. So we tried to print our first dictionary, which was this one, so A1 and B2, and we see that the modification that we did for the key B in the chain map also impacted the dictionary 1, because we see that dictionary 1 is now A1 and B100, which was initially A1 and B2. So this is how actually we see that updating a value associated to a key from a chain map can also directly impact a dictionary. Now, what if we want to add a new dictionary, for example? In order to add a new dictionary to our already existing chain map, we can have a new chain map, for example. Simply, we write down the CM, the name of our first chain map. Then we use the new child function. This is the function name that we need to write down, and then we are associating it in parentheses with a new dictionary, which has one element only. The key is E, and the value is 50. And all of this is assigned to a new chain map, which is called cm underscore new. So when I run the code one more time, we come back here, we see the new chain map with extra dictionary. So we are having the new dictionary here with key E and its associated value 50, A1, B100, and B20, and C30. So this is basically how we can create a new chain map using an already existing chain map with adding a new dictionary. Again, here we could have, for example, a new chain map from the second chain map, because the second chain map that we created was this one. This is the second chain map using all these three dictionaries, dictionary 1, dictionary 2, and dictionary 3. So this is the chain map 2. So we can have, for example, chain map 2, and then we are going to add a new dictionary to it. So we are creating a new chain map from the chain map 2. We are using the new child function to add the new dictionary and insert it, and then assign it to our new chain map 2. And the dictionary that is being added is having one key, which is E again, with its associated value, which is 50. Then we are printing it out saying that new chain map with extra dictionary 2, and then we are printing it in the output. So when I run this code, we see that this is the original second chain map was A1, B2, B20, and C30, and then D40. Okay, so this is our second chain map. Or we see that here when we are having the first dictionary with the key E and the value 50 is being added there. Okay, so this is actually how we can have it uh, in the output. This is how we can create a new chain map from an already existing chain map by adding a new dictionary. So let me comment this part because there will be a lot of things in the output, so it's a bit hard to manage everything and not get lost easily. So now we are going to learn how to convert a chain map to a regular dictionary. Okay, in order to do that, we are using this keyword, and in parentheses we simply write down the name of our chain map, which is CM, and this is the dictionary that we are creating. So this is merged underscore dictionary is the regular dictionary that we are creating here from the CM chain map. Okay, and this dictionary keyword is going to convert the chain map to a dictionary and then assign it to merge dictionary. And then we are going to print out the merged dictionary. So when I run this code, it says the merged dictionary is B, C, and A. Okay, we are not having E because we didn't work with the CM new. We worked with the CM, so the initial chain map we worked with. Okay, and you see it here, the merge dictionary is having 3 elements only. So A, C, and B, and we are having one B. If you remember in the chain map, we were having A, B, and C, but because it's not possible to have duplicates key, it is going to take the first B that it encounters from this dictionary. So it is just simply keeping one B, which is the first B that it encounters. Then all the unique, let's say, keys are kept. So then C and then A is there. So this is how we can merge dictionaries. And finally, if we want to delete, for example, one key from our chain map, when we have the del keyword, the name of the chain map, and then the name of the key, we can remove the key B from and its associated value from the CM chain map, and it is going to again affect the first dictionary. So here we see that after deleting B in chain map, we are having, so this was the initial chain map. Just remember, we are working with the CM always and not with the newly generated dictionaries here. Okay, so the initial chain map was A1, B2, B20, C30, but here after removing B, we are having A1. So A1 is only there, A1, B2, B2 is removed. You see it here. But the second B from the second dictionary, which was inside our chain map, B20 and C30, remains the same. But this A1, B2, this B part is removed. So only A1 is there. And we also see that it affects our dictionary as well because we are trying to print our dictionary as well. So this was the only original dictionary 1, A1 and B2. However, after removing B from the chain map, we see that it also has impact on our dictionary 1 because we see that the dictionary 1 after deletion is only A1. So this B part has been removed. So to wrap up, in this video, we learned about chain map and we learned how to work with them, how we can combine multiple dictionaries into one chain map, and how we can use a chain map keyword to merge these two dictionaries into a unique chain map. Then we learned how to access the values of a chain map. We write down the name of the chain map and then the key that we want to access its associated value. We learned how to update values of a chain map. We learned how to add a new dictionary into an already existing chain map using a new underscore child function. Then we learned how we can convert a chain map to a regular dictionary, and we learned that only unique keys will be kept. So if we are having two keys with similar and identical name, in the regular dictionary, we are going to have only the first key that it encounters. For example, if we are having 1b equals to 20, and 1b equals 100, we are going to take the 1b, which is equal 20, because this is the first b that we encounter, in fact. Then we learned how we can delete one key and its associated value, and we saw that it not only has impact on the chain map, but also has impact on the original dictionary as well. Thank you for watching. Hi, welcome back. In today's video, we are going to have some coding exercises for chain maps. So here we would like to have managing configuration settings. So a chain map can be used to handle configuration settings, where user-defined setting override system defaults. Okay. So here, first of all, we need to import chain map from the collection module. Then, for example, the default configuration of our system is the following. We're having a dictionary that is having 3 elements. So theme is the first key, font size is the second key, and language is the third key. So for the key theme, we are having its associated value, which is light. For the key font size, we are having its associated value, which is 12. And for the language key, we are having its associated value, which is English. Okay, so this is the default configuration of our system, for example, and displayed in a dictionary. Then we can have a user defined setting. For example, this is the when you buy, for example, a cell phone, this is the default configuration that comes with the cell phone when you turn it on. But then it asks you some questions that you can customize the configuration setting of your cell phone. For example, you prefer dark theme, or you prefer to have a larger font size, or even if you want, you can have another language. For example, you don't want to have the default configuration of your cell phone to be English, you want it to be French, German, Chinese, etc. So it depends on you, and you want to have a customized configuration. This is what we call user-defined setting or user configuration. In this case, for example, cell phone that I bought comes with a light theme and with the font size of 12 with the English language. However, I would like to have my font size to be bigger, and the theme, I don't want it to be light, I want it to be dark. Therefore, I have my own defined configuration. So I would like to have a dictionary to present my data. So when I enter the data, it can be presented in a dictionary, for example, inside the cell phone. It is it is posing some questions. Based on my answers, it is, for example, preparing a dictionary with keys and the associated values. So the key is here theme. I want it to be dark, and the font size I want it to be 14 instead of 12. Then using a chain map, we can combine the user configuration and the default configuration and assign it to a variable that is holding our chain map called config. Then what is going to happen is the following. This is the default configuration. When the user defined configuration is there, we're going to have the user defined configuration overriding the default configuration. Okay, so the theme is now dark. It's overriding the theme light, which was the default setting. And the font size is now 14, which was the default size was, for example, 12. So now that we have it on a chain map, we are first putting the user configuration and then the default configuration because we want the user configuration to override the similar keys there. So this key is shared between two configurations. Therefore, I want this theme to override this theme, which is the default one. Now, when we print, we see that, for example, we want to print the theme from the config chain map. This is the keyword, and this is the key, let's say, of the chain map, and this is the name of the chain map. Therefore, when we run the code, we see that the theme is dark because the user preference overrides the default preference. Okay? But then when we talk about the font size, we again have the key font size from the config chain map. And when we print this, we see that in the output, we have the font size of 14, which is the user preference that is overriding the default setting and configuration. Finally, when we want to discuss the language in which the system is presented, for example, we write down the key language from the config chain map. However, here we see that the language remains the same. It's English because the user did not define any customized configuration apart from the English, which was the default setting. So this is why we see that the language remains the same. However, if we wanted to have a different language, it would have been something like this. For example, I could say language. Then we could have, for example, French here. Okay. So now that I added a new key to the user preference, the user configuration, this language overrides the default language, which is English. So now when I rerun the code, I expect to see French in the language because now it is also customized. So this is how we can have a managing configuration setting, for example, for a cell phone or for a laptop. When we buy it, it has a default configuration, but we are going to customize it, and this can be done through dictionaries and more particularly when they are combined. So we are having a chain map and the user preferences is going to override the default setting. Thank you for watching. Hi, welcome back. In today's video, we are going to have a coding exercise with respect to chain map in Python. So we're going to talk about variable scope resolution. We're going to have three different scope resolutions, one for local, one for global, and then the last one for built-in. So a chain map can be used to simulate variable scope resolution in Python where local variables override global variables, which in turn override the built-in variable. Let me illustrate it with this example. First of all, we are importing the chain map from the collection module. So here we are having the built-in scope. So the built-in scope, this is the default values that we are having here. These are the default values in this built-in scope. So we are having the max value 100, and we are having the mean value, which is 0. But we want to have global and local scope as well. So in the global scope, we are going to have the max value, which is 50. So when we are having the global scope with the same key, which is the max value, we are going to have this, let's say, variable, this key of this dictionary overriding this key, okay? Because we are having global that overrides the built-in scope, and we are having a local that is going to override the global and the built-in scope. So for the local, we are having the max value here. So the max value 25 is going to override the global scope key max value, which was itself overriding the max value from the built-in scope. And here we also have the current value keyword. So the current value keyword only shows up here in the local scope. For the global scope, we are having only the max value, which is going to override this built-in max value, and which is going to be overridden by the local scope max value. And also we are having a mean value that shows up here only and has the value 0. So now we would like to have the priority of the local scope, then the global scope, and then the built-in scope. In order to have this, we are using a chain map to combine these three dictionaries. So the local, global, and built-in, and the chain map name is the scope. So now if we are going to have the max value being printed in the printed out in the terminal or in the output, we write down the key called max value and the name of our chain map, which is scope. Then when we are having this one, we are going to have the number 25 in the output from the local scope. Why? Because we are having a dictionary, a chain map, let's say, containing all these three dictionaries. And because first we are having the local scope dictionary there, it is going to use the first max value that it sees. So this is 25 that it is going to be shown in the output. So max value key from the local, from the scope chain map. Then we are going to have the mean value from the scope chain map. So mean value, we know that it's not going to be in the local scope because we don't have it. In the global scope, we don't have it. In the built-in scope, we have the mean. So the 0 is going to be printed in the output. And finally, we are having the current value, which is 10, and it is only defined in the local scope dictionary. So it is going to print number 10 in the output. So when we run the code, we see the max value is 25, exactly the max value, the value for the max value keyword from the local scope is printed in the output. Then we are having the mean value, which is 0 here. And then we are having the current value, which is 10 as we expected. Let me first print our chain map here. This is our chain map. So I'm going to print scope. So when I run the code, we see the scope in the printing in the terminal. So first, because we are having for the chain map to create it, we combine first the local dictionary, then the global scope dictionary, and then the built-in scope dictionary. So this is the local, this is the global, and this is the built-in dictionary, that all of them are combined to create our chain map, okay? So this is why when we are having the max value key being printed from the scope chain map, this is the max value, this is max value, and this is max value. So there are three keys with max value name in this chain map distributed in three different dictionaries. However, the first one that the chain map sees is going to be the output. So this is the first max value that the chain map finds when we call it. So, and its value is 25. So this is why 25 is printed in the output. So this max value overrides this one and this one. Then we would like to have the mean value. So the compiler starts from left. The mean value, do we have it here? No, here, no, here, no, here, no. But here we are having it, mean value. So the mean value is being printed in the output. Then we are having the current value. So here it's not there. The current value is here. So 10 is printed in the output. So the first one that the compiler sees as we move forward from left is going to be printed in the output based on the name of the key. So for example, the key called max value from the scope chain map. So this is the scope chain map. The max value, the first one is 25. This is why 25 is printed in the output. So this is a good example of how variable scope resolution can be performed and can be taken care of using chain maps. Thank you for watching. Hi, welcome to this video. In today's video, we're going to have an introduction to heap and heap queue in Python. So a heap is a special tree-based data structure that satisfies the heap property. For example, in a mean heap, which is the default in Python's heap queue, the smallest element is always at the root. And in a max heap, the largest element is always at the root and can be simulated in Python. So Python provides the heap queue module, which implements a binary heap using a list. It is efficient for priority queue operations, finding the smallest or largest elements, and optimizing algorithms like shortest path. And we use them because getting the smallest and largest element is very fast in Python using heap queues. In the following videos, we are going to have some coding exercises and have some figures of discussing the tree-based data structure and see how we can implement heap queue to have our results in the root, for example, the smallest one or the largest element in the root. Thank you for watching. Hi, welcome to this video. In today's video, we are going to have a coding exercise to understand the mean heap concept. So in a mean heap concept, the smallest element is always at the top of the tree. So here, in order to use the heap queue, we need to import it first. Then we would like to have a list called nums, and this list has 7 elements: 3, 1, 4, 1, 5, 9, and 2. So these are the elements of our list called nums. Then in order to convert this list into a mean heap in which we can see the smallest value at index 0, we are going to use the heap queue and then the heapify function. So this is the heap queue that we are using, that we imported in the Python. Then using the heapify function, we are going to convert it into a mean heap. So basically, a mean heap means that the smallest element is at index 0. Okay. In order to have a mean heap, we can use the heapify function, and in parentheses we are having the name of our list that we want to convert it, which is nums. After doing that, we can simply use the print function to print nums for us. So when I run this code, in the output we see mean heap is 1, 1, 2, 3, 5, 9, and 4. Just remember that heapify function is not going to sort our list for us. Okay, it is going to only move the smallest element to be at index 0. So you see that the smallest element in this list was 1, and now 1 is index 1, the index 0. So this is how we can actually see how heapify function can convert our list into a min function and has its first element to be the smallest element in the previously mentioned list. For example, in nums, we were seeing that number 3 was the first element, but in the output, we see that number 1 is the first element, which is the smallest element in our min heap. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how we can add one number to our heap. In order to add a number to our heap here, we are using the heap push function. So we write down the heap queue, which is our imported library here in Python. Then we use the heap push to push a new value to our heap. And then we need to have two arguments. So the first argument is the name of our list, original list, let's say, that we converted it to a min heap. So this is the name of our min heap, and then the number that we want to add to this uh, min heap that we are having here, nums. Okay, so when we are adding this, after that I print the nums here. So when I run the code, we see that the min heap was originally look like this: 1 1 2 3 5 9 and 4. Now we are adding number 0, so now it starts with 0, and because it's the smallest uh, element in this min heap, it is going to be at index 0. For example, here, if I had number 10, for example, when I run the code, we see that after adding 10, 10 is inserted at the end here. But because we are adding a number that is smaller than the other numbers, which is 0, and we are having a min heap, 0 is going to be the first element since it's the smallest element in our min heap. This is how the logic would work. So in order to add a number to our heap, we simply write down the heap queue, then heap push. Heap push will help us to add it. And then in the parentheses, we are having two arguments separated by a comma. First, the name of the min heap, and the second is the value that we want to add to our heap. And after that, we are going to simply print it out. Okay. Then what if we want to remove the smallest element in our heap? Here, in order to do that, we simply have the, again, heap queue dot, this time heap pop. So for adding a number, we used heap push function. For removing the smallest element, we are going to have the heap pop function, and in parentheses, we write down the name of our min heap. And all of these are assigned to smallest variable. Okay, so it is going to give us the value that is going to remove, and it is assigned to smallest. So here I'm just simply printing out the smallest element that has been removed, and then after removal we are printing out our min heap one more time. So we see that here was the previous version of our min heap, which was starting from 0. Then we mentioned, okay, remove the smallest element, which is 0. So we remove that, and 0 comes from here. Okay, remove the smallest element, and smallest is being printed, which is this number 0. Okay, so this function helps us to remove the smallest element using the heap pop function. From the min heap nums, we are going to remove the smallest element, and the smallest element is assigned to a variable called smallest. And in order to understand which number was the smallest element in that min heap, we assign it to smallest and print it out, so we know that which element has been removed. Then we are simply printing heap after removal. So heap after removal looks like this, because In the previous version, we were having this and it had a 0, but here we remove the 0 and we see that we have no 0 in the after removal. So in order to review, in order to add one element to our heap, we simply use the heap push. In the first argument, we write down the name of the heap that we are having, and the second argument is the value that we want to add. Okay. After adding, and this is basically it. So this is how one value is added. So if the added number is the smallest number in the heap, it is going to be placed in the first place. So you see that 0 that we added here is the smallest number in the heap. This is why 0 is the first element. But if I enter 10 here, for example, instead of 0, it's not going to stay as the lowest element. So the lowest element is 1, so the min heap is going to start from 1, and 10 is added at the end. Okay. So if I add, for example, 5 here, again, we see 5 at the end because 5 is not the smallest number. So the min heap is going to start with the smallest value. And just note that it's not a sorted heap. Okay. It's only a min heap, meaning that it is going to start with the smallest element. This is what it's going to do. Then we learned how to remove an element, remove the smallest element using the heap pop function, and the name of the heap is inside the parentheses. And in order to find that what is the element that we are removing, we assign it to a variable called smallest, and we print out the smallest here in the output. Also, after the removal, we print the heap to see now how the heap looks like. So we see that 1 is the first element in our heap here, because here we were inserting number 5, and number 5 was the last element. So here we remove the first element, so we had 2 number 1, and now we remove one of them, and we see only one number 1 still is there, and we are having it right there. Thank you for watching. Hi, welcome back. In today's video, we would like to have a coding exercise using heap queue for priority queues. Here we are importing the heap queue module in Python to use it. Then we are creating an empty priority queue here for our tasks, but it's in a form of a list, and we name it tasks. So this is our priority queue. Then we would like to add tasks to this priority queue. In order to add tasks, we know that we can use the heap push function in order to add tasks to our heap queue using the heap queue module to our priority queue. But one thing to mention here is that we can give priority to different tasks. For example, here we would like to push back to this priority queue, but we want to not only add the task that needs to be performed, but also its priority. So its priority is 2. Write report. So this is with priority 2. Priority 1, which is the first thing that we need to do, is fixing the bug. And after fixing the bug, we are going to then start writing the report. And finally, we are having the priority 3, which is emailing the clients. So this way we are adding tasks to our priority queue, which is called tasks, using the heap push function, and we are also giving the priority that needs for each tasks to be executed. So now I'm, for example, adding the fix bug with the first priority. So the first thing that we need to take care of is fixing the bug. Then writing the report, for example, with the priority 2, and emailing the clients with priority 3. So this heap automatically organizes tasks so that the lowest priority number, which is fixed bug here, is at the front. Okay, so first of all, it is going to be executed, and then this one, and then this one. Okay, so internally, the heap maintains order based on the priority value 1, then 2, and then 3. Now, in order to see how we are going to have the outputs and ask the compiler to print us some tasks based on their priority, we write down a while loop here to retrieve the highest priority tasks. And here we are simply printing out the tasks that are being processed. So when we are printing it out in the output, we see that first of all, we are having the fix bug with the priority 1. Then we are having the report that we need to write with the priority 2. And then we are having the emailing of the client with the priority 3. This is how we can have it done with respect to the priority level. So in this video, we learned how we can use heaps to work as a priority queue for us to have different tasks being added using the heap push function with their level of priority. So if the level of priority is lower, it means that it's the higher task that needs to be done sooner. So the lower number means that, for example, when we are having number 1, it has priority over number 2 and then over number 3, etc. until the end. Then we use a while loop to simply print based on the priority. And now here we see in the output priority 1 is first performed, and then now priority 2, and then priority 3 in the output. Thank you for watching. Hi, welcome back. In today's video, we are going to use the min heap and create a min heap from a list, and then understand what are the 3 smallest elements in that heap for us. Okay? In order to do that, first of all, we need to create a min heap from the list. After doing that, we are having a list called nums, and here are the elements of the nums. Here, in order to convert this list into a min heap, we learned that we can use the heapify function. In parentheses, we write down the name of our list, which is nums. Then we print our min heap. So our min heap is like this: 1, 1, 2, 3, 5, 9, and 4. Okay? Now, in order to find the 3 smallest number in our min heap or in our heap, it's very easy to use the n smallest function. So we use the n smallest function, and in parentheses we write down first the number of numbers that we want to have. For example, we are looking for 3 smallest elements, therefore I write down number 3 here, and then we are going to write down the name of our heap, and this is assigned to a variable called 3 smallest. So it is going to assign our 3 smallest values in the nums heap and assign it to 3 smallest. Okay, and then we are printing simply the 3 smallest here heap in the output. So when I run this code, first of all we see the min heap, and then we see the 3 smallest elements of that heap, which are 1, 1, and 2. Okay, so if we wanted to have, for example, 5 smallest elements, we could simply write down number 5 there, and we could say 5 smallest element. We write down number 5 here, and we see that 5 smallest elements that are 1, 1, 2, 3, and 4 are being printed out in the output. This is how the n smallest function is going to help us to find simply the smallest elements that we want to find in a heap in sorted order. Thank you for watching. Hi, welcome back. In today's video, we are going to learn how to find three largest elements in a heap. Here is my list called nums, and these are its elements. We use the heapify function to convert this list into a min heap. Okay. Then, first of all, we print our min heap. So this is the min heap 1, 1, 2, 3, 5, 9, and 4. This is how we print it out in the output. So min heap ensures that the smallest element is at the beginning, and that's it. Then, in order to find the three largest elements, without modifying the heap, we use the n largest function. Because we are looking for three largest elements, we write down number 3, and this is the name of the heap in which we want to find the three elements. And this is assigned to three largest. Okay. So when I run the code, we see that in the print here, three largest elements, we see 9, 5, and 4. So this n largest function is going to give us the three largest elements of the nums heap and assign it to three largest heap, then print it for us in the output. So we see that three largest elements are three largest is being printed, and then are 9, 5, and 4. So this is how we can have the, for example, three largest elements, or for example, the 5 largest elements. If I change it to 5, you see that 5 elements that are the largest ones are being printed in the output: 9, 5, 4, 3, and 2. This is basically how we can use the largest and largest function to return us the, for example, three largest elements in a heap. Thank you for watching. Hi, welcome back. In this video, we are going to show how the heap works when we are adding a new number to it, and how it can find the smallest value to put it at the root. So just imagine that this is our heap representation: 1, 1, 2, 3, 5, 9, and 4. So we are having 1, 1, 2, 3, 5, 9, and 4. This is our tree. Okay. Then we would like to add one element, and we want to add number 0 as the element. So we're going to use the heap push function, and it is going to basically insert 0 at the next available position, which is the end of the heap. Okay, the end of the heap is here, so it is going to add it here. But what we see in the output is this one. For example, is this one. Sorry, is this one. Okay, because the number 0 is the smallest element, it is going to be at the root. And when we print the heap after insertion a small number like 0, we see that the heap looks like this. For example, it is having 0, 1, 2, 1, 5, 9, 4, and then 3. Okay, but how do we get to this output? This is the final heap that we see when an insertion of 0 is done, because 0 is smaller than any other element in this heap. So this is our heap. We see that if we add 0, 0 is the smallest element here. And at the end, we are going to see this one, okay, which is like this. But there are some steps that the compiler goes through to get to this final heap that show us in the end, in the output. In order to understand, so here was my original heap. We added one number, which is 0. So 0 is smaller than the smallest element in our heap. So we are going to insert it, and we are going to insert it here at the end of the heap initially. Then we are going to have a comparison. So the comparison would be like this. So here is the list representation after adding number 0. So 0 is here, but 0 is going to be compared here. Okay, so 0 is smaller than its parent. Okay, you see it here. So 0 is smaller than its parent. So the parent is 3 and 0 is the child. So because it's smaller, we are going to swap their position. Okay, so we are going to swap their position. So 3 is now down and 0 is a bit one stage higher. Then we are going to compare this 0 with this 1. Okay, so child is smaller than its parent, so we are going to swap them as well. So here would be the output. We are going to have 0 here and we are going to have 1 here. Why? Because the child is being compared with its parent, and when it is compared with its parent, it is smaller, so we are going to swap their position. So when we are swapping their position, we get to this tree. And now when we are having number 0 here, and this number 0 is lower again than its parent, which is number 1. So there we are going to swap their position again. And finally, we are going to reach to this final heap that we see in the output, because now the smallest number is at the root. So this is the numeric representation of our heap. So this is in the end the heap that we are going to get. But there are steps that it goes through to find the smallest element in our heap, to put it and move it at the root node 0. So it was an interesting example to see what the procedure is for the compiler to move a small element to the node 0, to the root node. Thank you for watching.